So I just want to start with, this is our tech memo protocol that Julian put together. That is the reference guide for the system. It's really amazing to have everything in one spot, and should have your go-to for anything that you have questions on or how to do. I'm going to walk us through some of it just to go through, and then tips from there. But basically, it's got, I think everyone's probably looked at it, but how to install LFDCS. So right now, it's just you put the 2 files in your home directory, you put a couple lines of code in the terminal, and it should say LFDCS is installed. I won't go through it, but if anyone needs help with that later, we can definitely look at that together. The biggest issue I think people have is with IDL often, and so when you have an IDL problem, I will say I do not know IDL, and their help department is really good, so if you have an issue in installation, definitely get in touch with them. A lot of things we've just discovered as well recently is Apple's new processor type. They've completely reconfigured how they do it, and that's caused a lot of problems. And so Mark's gotten a couple workarounds for that, and we're going to work on hopefully having this fixed in the newest version, so it'll be pretty clear of what to do. So that's installing. So it has everything in here for each program. So LFDCS has a program for everything you want to do. There's different programs for the call library, so whether you want to build a call library, whether you want to add calls to a call library, you want to look at it and assess it, and then the programs for processing, reviewing, exporting detections. All of these things are a different command or program that you call in the terminal. And so we'll go through all of them, but this reference guide walks you through the code with each program in terms of how you put it in the terminal and all the different types of arguments you can add depending on what you want to do. And then there's the whole second part is the real-time analysis protocol, which Julianne will go over in the second half of the day.
What is the number of this tech memo again? Cool.
The number?
Yeah.
I don't know.
Not that you should have it memorized.
I should know that.
If you just
for Googling purposes.
If you just Google LFDCS reference guide, it should, the first link that pops up should be the Know It repository. Like you can download it right there.
And it is on the Robots for Whales website.
Yes.
Along
all the way
with
down at the bottom.
the video tutorials from the last DCLDE workshop, and so we will also post these there as well. So you'll have 2
resources
recordings you can look back up with similar information. Okay, so I'll just start with, oh, sorry guys, it doesn't have a jump to because it's so word, but there's all the information, so how to use the reference guide, our contact information if you're in trouble, introduction of, just a reminder, like we'll go over this now, but what happens when you open the program, what does everything look like, pitch tracks, installation. And so I just wanted to go to the first one. So once you install and process, we'll get there. There's a lot of setup, which we're hoping we're going to solve soon. So just to show what this looks like, for each program, it'll show you what you should enter in the terminal. So the first line is always directing your terminal to your process folder. That's where all of the programs for LFDCS lives. You then have to call IDL, which is the coding language that LFDCS was written in. And so that way then you can do everything that the program will do. And we'll go over each of them, but basically once IDL opens, you'll get an IDL caret in the terminal, and then you'll type which program you want to do, and then the following commands that make sense for that program. So that's what we'll go over now, is each argument for each program. And then below that, there's always an example of what it would look like for what you would type for that. My recommendation at the moment is having a little code text file. Nope,
Jen,
not that one.
Yeah, DCLDE, LFDCS example code. Yeah, there you go.
So especially if you're doing something daily, it's really helpful to just have a code file with the main commands that you're going to run, so you can copy and paste it in the terminal rather than having to remember what you're doing, typing and pasting again. And this way, it reduces typos, which will reduce frustration. And then if you're just changing your output or where you're reading things in, you can do it here easily and then copy and paste it back in. So I'll work off of this to show you how I do it and how we do it. So the first thing, if you're new to the terminal on your Mac, is down below there should be a terminal. And if you don't have it on your dock, it's in your Finder, under Applications, under Utilities, and there's your terminal. So at the moment, LFDCS is purely terminal based, so everything is operating through here. And so the first thing you do is you direct it to your process folder, and so just so everyone's aware, what we do also is we put LFDCS as a shortcut, the folder on your Finder, so you can easily go there. It's under your home directory in projects, detectors, LFDCS, and so you can just drag this folder over to the left and that'll pop that there so you can always access it. And so basically we were saying we want to go into this folder, process, which contains all of these .pro files are what make the program run. So I'm going to copy my path, and then you type IDL, and it should, if it's working in your license, show you this, and it'll give you your license number. If IDL does not work, then that's something that I would contact IDL about if for some reason it's not showing up.
Is IDL expensive?
Yes.
For you, yes.
So right now, right now, IDL is you need a full license. For non-academic, it's about $3,000.
For academic, it's like $400.
For NOAA.
Which is why,
For
yes,
NOAA,
for
it's
NOAA, it's expensive.
$3,000. However, for LFDCS 2.0, which is coming to you soon, all you need is an IDL runtime license, which should only be, I believe it's under $200 one-time fee.
And that change is also what will allow it to be run on those machines.
Then you can also do it.
That's part of the same effort.
Yes.
Yes.
So that's we're working on that with.
Okay.
Yeah. So we're working on it. It's not quite ready yet. I'll show you a flashy idea of what it will be, and then we'll let you know when it's ready. Okay. So the first thing to do is to process our data, and so we can look at a parameter file, which is what tells LFDCS what to do. And everyone in the test data set in your LFDCS files should have a test parameter that you can start with. So you can just take it, you can duplicate it, and then you can change the metadata that I'll show you what you would change. And you'll have all those parameters that Mark was talking about that he's looked at, tested, and tried to make sure it looks as good as can be and seems about right. So there's a parameter file folder in your LFDCS folder. And we can just look at test. I believe what comes in your package is this Davis et al. And a test. The Davis et al. Is just what we used for those papers, so you can grab that and see that. There's two different ones here. And so for right whale, humpback, basically everything except for fin and blue whales, we use the 2 kilohertz sampling rate call library. For fin and blue whales, because they're super low frequency, for blue whales especially, we decimate the data again, so we do a second processing where it zooms into 60 hertz, so it's 120 sample rate, and then we have a different call library for blue and fin whales, and it just does a little bit better. Fin whales are picked up in the 2 kilohertz sample rate, but since we're doing the low frequency anyway, we tend to do the lower run. And the real time does the fin whale call types using the 2 kilohertz call library, so it works. Kind of, depending on what you're looking for, look at that stuff. Okay. Is that okay for everybody's eyes? Okay. So all of this is metadata that we would change. Sometimes all of it, sometimes only pieces of it for each run. Everything below the call library, these call library files, and down, these are all the parameters that I don't touch because Mark made it look great and I trust it and it seems to be working. But these are all the things that you can fiddle with that he mentioned in terms of how the pitch tracker works, how the background noise is computed, and that kind of thing. These are the two call library files. So the first one is what you would probably direct it to if you make a new call library or if you change it, and we can see where that is, but that's for the narrowband, so anything that we would be doing. The second file is kind of a placeholder really for the broadband that currently isn't something we're using, but is there in theory. Then everything here is the metadata that you want to look at and change. So the experiment is really just the name for you to know what project you're running. And this will come out in the metadata information in the header file when you export detections. So it's really for you to be able to have information that makes sense to you and keep track of things. I typically keep the experiment name as whatever I have the name for the project, and I usually name the parameter file the same name, just to keep it simple. The in directory is the input for your sound files, so which audio you're going to process. And you can type it out like this. You can also drag the folder right to that spot if that's helpful. So if you have it open, you can drag it and it'll write the path. Handy trick. Out directory is where you want your output to be. And so one thing to keep in mind with the output, sometimes people do it on your desktop. If you don't have enough space on your computer, it'll cause an error. So you want to make sure wherever you're writing files to, it's big enough. And remember, it may not be as big as your audio file. So if you have 48 kilohertz sample data and you're resampling at 2 kilohertz, you'll have a lot smaller output. However, you're still going to have a decent sized output. So just keep that in mind as where you're putting your files. The start date is just the starting date to calculate detections from. So when you get your detection output, it'll say second since start date. So this can be 1970. You just want your date to be before your audio files. You can make it the start of your actual audio files. It's kind of up to you. But to have a safe place, I always did like January 1st, 2006, or something that was before most of my sound data to have as a fail-safe. Platform type, likely going to be mooring, but that could be mooring, glider. That doesn't matter, right? It's just metadata. Yeah, so whatever you need it to be. Platform ID is also metadata for whatever you need it to be, so the ID of whatever your recorder is. Instrument type should also be whatever metadata it is for you, so soundtrack, glider, DMON, whatever it needs to be. File date spec, this is how you tell it to read the date and time from your audio files, so you want your format to match what the audio files have for your date specification, and so just to show, is this just output? Well, in this case, our sound files had year, month, day, underscore, hour, minute, second, in the file date, spec in the title. File extension, what is the extension of your sound files, file format. This Mark has different reader files for, so if you're getting an error, we should check to make sure what you're putting. But there should be an AIF, there should be a WAV. We have WAV files that are 24 bits instead of the typical, so we have a WAV 24. So this kind of helps if you're getting errors with your sound files. I think everyone, for the most part, is having standardized sound files now, but yeah.
Does it work with FLAC?
It is working in the new version on Windows. I've done it successfully.
Really?
Yeah, so the problem is there's no FLAC reader on Macs, but it will work.
Okay, so that, yeah, not a
So but it will work on Windows and
Wow.
Linux with the right file reader, so you may have to help install something, but yes.
One thing to mention, so instrument type there are some instrument types that you don't need to do the file date spec, the file extension, and file format. DMON is one of them, but there are others. Yeah, that's, so the trick is that while the sound formats are the same, like WAV and AIF, there's a billion different ways to carry the time and date of the start of the recording. A lot of people put it in the file name. There are other file formats that hide it in the binary file itself. And so depending on what file you use, what type of recorder you're using, this might look a little different.
Yeah.
So for instance, if you're using a DMON, you would just say instrument type DMON and you wouldn't have any of that other stuff.
Yeah. And we can
help
some
you
we can
figure
help,
out.
But also have a couple examples of those special types that can be in the next distribution maybe so that they're
That's a good
set.
idea.
Yep. Okay. Instrument ID, this at the moment directs to channel. So if you have multi-channel data and you don't want to do the first channel, or maybe you want to do the second channel, you can indicate that here and it will process that channel. So it's one channel at a time. So if you want a different channel, you have to indicate that here. Originator is just metadata, so who ran this, if you ever want to look back and see why is there a mistake? I did it. Location is also metadata, where is the data, or where are you, so however you want to use it. Time zone metadata, come across lots of time zone issues from data from different people, different areas. So I'm a big fan of tracking that if you want to. Anything you don't, so a lot of these that are unnecessary, you can comment out or you can delete altogether. I believe the reference guide says what's actually essential for what you need. The file duration is the size of the output files. So we used to do 900 because the computer was limited in speed by output of file size writing, but I've since increased and it seems to be working better with our newer computers. So you can play around with that. Frame, overlap, and smooth. These are the parameters we found work really well with a 2 kilohertz sample rate. So you can play with that, but I wouldn't recommend it because then the spectrogram looks really bad. But if and when you need to shift and make a different call library at a different sample rate or using different call types, that's where you would play with these to see what looks better and what produces the best output. And so just to give an example, for the low frequency run, there's just one addition, resample rate. And so this you could also have in the other one if you have 48 kilohertz sample data and you want to do 2 kilohertz, you would have this resample rate line in there and it would be 2000 or 2000 hertz. For our low frequency blue and Finwell processing that we do 128 hertz. And the overlap and smooth is just, the overlap is slightly different just to give it a little better look for that sample rate. And then here the difference is the call library, we've pointed it to call library GeoMLF blue, and so I'll show you guys those different ones, and you'll change the ones you create as well. There's 2 different ways to reprocess data if you're going to do a lower sample rate decimation. You can do it from the original audio like this, which is the same as what we just did. You can also take data you've already processed and resample that again. And that's much faster because you don't have to recreate the spec audio from raw data. You're taking the spec audio and recreating spec audio from that. So it's a bit quicker if you already have it processed. And in that, what you would do is your indirectory would be from your LFDCS output files, and so, sorry, I feel like I'm jumping all over the place. When you process LFDCS, you get 2 folders. There's spec audio, and that contains all the spectrogram images. That's that first step that Mark went through, was the conditioning, creating the spectrograms. It's called the spec audio. And then the second step of LFDCS is doing all the pitch tracking and classification, and that goes into an LFDCS folder. So in your output, if you point it to the spec audio as your input for processing, it'll then reprocess that to the sample rate that you And so then the instrument type in this case is spec audio, and so then it automatically knows, oh, I'm already reading my own stuff, I know what I'm doing. It has this file date spec, instrument ID is 0 for spec audio, and then you can resample at the rate you want, and then that's quicker than from raw data. Both give you the same results, so just options. Okay. So to process data, you set up your parameter file. You need a parameter file for every output that you want. So you'll often, that's why I name mine very specifically, usually with the project name to match the audio files. We have the regular run, and then when we do the low frequency, so the 128 sample rate, we'll add an LF at the end. So we have a parameter file for each. The low frequency one has LF at the bottom. So something just to help you to remember and go through. For processing then, you'll set up your parameter file, and then you come to your terminal, and then you can go to your code cheat sheet, and it'll say to process, this is the program, so it's reformat detect classify, all together, separated by underscores, comma, space, and then you direct it to your parameter file. So in this case, we have to go, we're in our process folder, which is here. We said we want to go up one folder, down into parameter files, and then you direct it to where your parameter file is. So in this case, we have in the test data set, testparam.txt, so that's what we want to run. I don't actually set this up, but we'll just give it a try.
Should work.
You hit enter, and then it'll say, are you sure you want to convert this recorder to NetCDF? So that's saying, are you sure you want to create the spec audio? You are not touching your audio files. So what's really great about this is that it's taking in your audio files and creating output that's totally separate. So once you have your spec audio and LFDCS folders, you can take that, you don't have to have them anywhere near your audio files, and you can do everything. And it's not changing or touching your audio files. So you don't have to worry about that, which is really, really nice. And this is just saying, are you sure you want to do this? So it's not like, are you sure you want to change your audio file? It's just, are you sure you want to run? And then another great failsafe is if you already ran this, it will ask you, it will say, there's already an LFDCS file. Do you want to overwrite it? And so this is good because any analysis that you do, whether you mark a detection as correct or incorrect in the program, is written into the LFDCS folder. So if you say yes here, you'll lose that. So this is a good check. In this case, yes, we do. I believe it's only like 3 hours. So what it does is you'll see a lot of different things, but it'll read a file and then write a bunch of files depending on how large you set your output size to. And so it'll do that through all of your audio files that you have. That's the first step, so that's creating the spec audio. And then this next part here is the pitch tracking process. And so it'll give you, in this case, we only have 3 hours of data for 3 days, so it's very short. But you'll get a time elapse for each file that it's writing. So you might have 10, 20, 50 of these. And at the end, it'll say LFDCS processing complete with a lot of hashtags. Or asterisks, sorry. Something exciting. So then if we look at where that went. So in this case, it came into the LFDCS test data set processed. Okay, so every output will give you these 2 folders. So whatever you name it to, when you open that folder that you sent it to, you'll have a spec audio and you'll have an LFDCS. And within there, it'll show you month folders, so it'll be year month, and then within that will be each file that fits under there. And remember, these files are the size that you set it to. So in this case, these are all 900 seconds, so 15 minutes. Same for the LFDCS, same structure. You'll have monthly folders, and then each file for the corresponding months. And then it also shows you your call library. So it writes the call library into here so that you always have that attached and you can look to see what was run. We've made it so that when we create a call library, we add the name of it to the end so you can tell what call library is there rather than having to go into the program and manage it to see. This is a quick, easy way to see what call library you ran. So in this case, this is our GOM9. This is what we've added to build humpback whale call types onto what Mark published on in this paper. It also copies the broadband call library as well. Okay, any questions so far? So next step, this is kind of our workflow too. So what we typically do is we process the data and then we export summary auto detection sheets, which gives us the number of detections for the species that we're interested in. And we do it species by species. So, and we do daily presence, but the export summary auto detections is a way to summarize the data into bins for the detections or the call types that you're interested in across a data set. And so in this case, we have export summary auto detections. You point it to the LFDCS folder. So again, there's spec audio and LFDCS. This is going to the LFDCS because these are where the detections live. The next command tells you the call types that you want. So we'll look at the call library and how you manage it. But in this case, these are all right whale call types. So 5, 6, 7, 8, 9 in brackets. The next command, so everything's separated by a comma, or the next argument is pointing it to the output file name. So if you don't give it a path, it'll put it into the process folder because that's where we live. Remember, you go to the process folder, open IDL. So if you forget to put paths anywhere, it'll dump everything into process because that's where we are. But if you don't want it to go there, you can actually put the direct path here with the file name at the end. .csv, it outputs a CSV file. The next argument is the number of bins of the time that you give it. So here we're saying we want 24 hours. You could do 1 days. You could do 15 minutes. So whatever you're interested in binning, you can specify the number with a backslash of the time bin that you want. You can specify the maximum Mahalanobis distance. So in our case, we do 3. You cannot put anything in there and it'll export all detections for that call type. So there's lots of options. The S date is the start date. So what you want to start your export summary from. So if you want to start the first day of the deployment, you can give it that. If you want later, you can do that. And the end date. And you do want to give a start and an end date. So otherwise it will just keep writing to infinity and beyond. One thing we've done, so with the different time zones, is we've standardized our analysis bins. So if we have data in UTC and local EST, for example, we want to have all of our daily bins in local EST. So one thing you can do is when you have data in UTC is shift the hours of the daily bins. And so that's what we do here, where we have our day bin starts at 5 o'clock and ends at 5 o'clock, so it'll give you day bins in your shifted time zone, so you can analyze accordingly. That was also a big mistake we found out halfway through the analysis. All right, and so just to show you what that looks. So if you run the export summary auto detections, this is what you get. The beginning is metadata, so this is what comes out from what you put. So if you remember experiment or study, it gives you whatever you had entered for that. Location, originator, platform, instrument, interval, and max MDIS. So anything that you tell it that you want to print out, it'll give you in the metadata. It then tells you what the column names are here with specifications. So start date, start time, end date, end time. So those are your daily bins because we did daily bins. You'll see 5 o'clock to 5 o'clock as we asked it to. And then it'll just remind you what call types you did. So it'll give you the call type, and then here it gives a little description of what that call type in your library actually is. And then the last, so for each call type, it gives you the number of detections in that bin for it. And then the last column is the summary. So how many detections overall for everything that you wanted do you have? So for us, we typically ignore individual call types. We just look at the summarized column because we're interested in all of the right well up calls, for example, and we go from there. And what we do is we have standard columns that we add here for our analysis that we just put on there, and then as we go through our analysis, we can mark whether or not that day has true calls, and any notes that we have as we go. So we can go through protocols, or we can share that if anyone's interested. Happy to. Okay. So now for the cream of the crop, we can browse our detections. And so that program is browse auto detections. First thing you do is you direct it to the output folder that you want to look at, the LFDCS folder. We always have to say call family 2, that's for the narrowband call types, so we're ignoring broadband. You can look at them, but we don't. The call type that you want to look at, so in this case we'll look at right well up calls, because we're right well focused at the moment. The maximum hello distance that you want to look at. This command classify will allow you to actually classify, so mark each detection whether or not it's true or incorrect. The manual species, this gives you buttons for that classification. So right now 9999 means correct, -9999 is for incorrect, 0 is unknown, and this last number is for unclassified. And so we'll show you what that looks like. But they're basically codes. You can change them, but this is what we've created to make sure it doesn't overlap with other species codes. And this way you can go through and have correct and incorrect classifications or verification markings. You can also tell it to start at a certain date if you want to open it up at a day. And then another thing you can do is this last command that we use often is to go through and only look at detections that were marked with a certain marking. So in this case, that's correct or unknown detections. So say you have an analyst going through data, they've marked correct and unknowns, and then you want to review those with them. Rather than going through everything, you can put that command up there and just go through the correct and unknown detections. And so again, the reference guide has all of this laid out with explanations and other commands you can add depending on what you're interested in. You can filter different calls in this for amplitude or other commands that are listed. Okay. So we'll give it a try, we'll open it up. And that's probably where you had to start elsewhere, but we will do that. Okay, so this data started while it was out of the water. Okay, so current.
The elusive aerial whales.
Huh?
The elusive aerial
Yeah.
whale.
Elusive aerial whale. Someone marked it incorrect, so that's good.
That's good.
That's actually, let's hold there. So whenever your data set has noise in it, you'll probably get pitch tracks in them. And that's a good, and some of those pitch tracks might look like actual real whale pitch tracks. And so it's good to exclude these things if you can.
That's why we manually
And it's also
verify.
why you manage noise, platform noise, so you don't get this situation.
Yes. Okay. Okay, so opening it up quickly, the different ways to navigate through. You can click on either side of the spectrogram to browse forward or backwards. You can, on the spectrogram itself, you can scroll with your mouse through, so forward and backwards. If you click on a button, it'll mark that previous one and jump automatically to the next detection. You can page forward and backwards, so that will take you to the next page of where there's a detection. So just to show you, so there's, I guess, the first thing, the pitch tracks show up in black and colored. The colored pitch track is the currently selected pitch track. It's colored by amplitude, so warmer colors is louder, bluer is softer. And so this one's selected. This is another pitch track within your current specifications you're looking at. And remember, we specified what we want to look at. If we didn't put call types in the Holonovus distance here, we'd probably have a ton of pitch tracks everywhere. And we can open that if you're interested. So page forward will bring you to the next new page of pitch tracks. So it'll skip that second one to the first new page. Same with backwards, you can do that. So if you have a ton of pitch tracks you're going through, that helps jump through them rather than clicking through each one. Zooming in and out will zoom in on the frequency. So you can zoom all the way out, zoom back in. If you want to jump to a different date, that's jump here. And that you have to specify currently in the terminal. And so it'll prompt you of how to format your date and time. So we'll jump to a few days ahead. And it'll bring you there. Now we're in the water. It's very exciting. You can change your volume and speed. So when you click on that, it'll prompt you down in the terminal for the volume. So it's always at 1. You can, I would jump slowly because you never know how loud it might be. So you could hit 2. It's always at a speed of 1 at first, but you can change that as well. But it will always ask you volume and then speed. So if you don't want to change one, just keep it at 1. Play will play that pitch track with like a buffer of a second maybe. And so it'll play the selected one. Play range will, when you click first where you want it to start and then when you want it to stop. So just careful with this because if you think you clicked around here but you didn't and then you like click over here, it'll play all the way from the beginning. So just so you're aware. But yeah, so you click it once and then you click start and end. Frequency range, you can zoom in on the frequency axis. So we can say, I want to look at 500. I'll zoom in there. And if you want to go back, you would just go back to 1,000. Okay. Toggle tracks, if you want to turn on and off pitch tracks. It's a very boring pitch track. Land on. Anyway. Clip, if you want to take a clip of something, you can hit clip. And then you can click where you want to start and, I hit clip twice. So I started here and ended here. And then you can save it at normal speed and volume, so 1 and 1, or you can do the selected. So if you have it sped up at 5 or you have it really high in volume, you can save it at that selected one. And you would hit S. I'm going to hit normal. And then you name it. So we'll just say test. And you always want to add the dot wave. So it makes a correct wave file. Thanks. And then it'll save it in your process folder. So remember, anything that saves, if you can't find it, look in your process folder. Autoplay, if you click on that, every time you move forward, it'll automatically play that pitch track. So if you're doing an analysis and you want to listen to everything, you can just hit that and keep going as it plays. And then auto class, I always turn that on when I first open it up. So it'll tell you for each pitch track what the call type is that it's classified as. It'll give you its Holonovus distance and the probability. I we did Holonovus. Oh, it's spelled wrong. That's why. There's so many bad pitch tracks in here.
Oh, that's what it is.
Okay.
Does it always plot like 45 seconds?
When you first open, but then you can zoom out.
The zooming does the time too. Okay.
Yeah, zooming just does time. And then if you want a frequency zoom, you would do the frequency range. Okay. So yes, so let's say you're going through incorrect. So you come through and you can do your markings that way. If you accidentally mark something as correct, you come back. Oh, that's not correct. You can change it to unclassified, and when you go back, it'll go back to unclassified. You could also, however you change it, so you can always change what you've marked as you go. Okay, I think that's it for browse. Anyone have any questions?
Does everyone know why you would play with the speed of audio playback? So there are calls that are lower frequency than your headphones or speakers, unless maybe you're doing your analysis in a movie theater you'll likely not be able to hear some of the low frequency sounds. So the way to make it so that you can hear them is to speed them up. So for instance, I like to listen to right whales at 4 times,
Ooh.
say whales at 6 times, and 12 or 24 for fin whales.
I do right whales at 2.
4 for right whales? 2? Really?
Well, I can't hear it. 2 helps me distinguish biological and boat noise sometimes. So sometimes there's like these weird rubbing sounds that look and
Sorry, my ears are a little
sound
older
like they
than
could be
yours.
an octave, but then when you speed it up, that really helps distinguish noise. But yeah, I mean, you can find whatever speed works for you. I think I had to enter do 5.
And the trick is to stick with the speed. Don't change it.
Yeah.
Because you're training your brain what that species sounds like at that speed.
Yeah.
If you change the speed, you're just going to have to retrain your brain, which takes a long time.
We have training data sets before going into analysis where we have analysts go through and listen to true marked calls, and that's where you can play with speeds because you know these are definitely a call. You can see what works for you, and then you can hear them at these different speeds. And that really helps, I think, to get your established mindset. Okay.
But here you're just looking at right way.
At the moment, yeah. So
but
let's.
you could like have many.
You could have many. Let's see. Let's
You
just as an
could
example.
reopen it with the better
Yeah, we can.
pitch tracks.
So I can take out the call types, for example. We'll keep maximum Mahalo distance 3, but you could have no call types and you could have no maximum Mahalo distance listed, and it would show you all pitch tracks. So here, when we look at auto class, nothing happens.
Okay.
That's weird.
Did you hit return down below?
Yeah.
It's weird.
Never had that happen before.
Just exit out of IDL
Yeah,
and start it
maybe.
again.
This is if you don't have a cheat sheet, how slow it takes. Okay, so if we just do browse.
Just do
Oh,
it.
sorry. It is.
There we go.
Okay. So this is, we didn't give it any call type specification or any Mahalanobis distance, so this is showing you all pitch tracks. Just to get an idea, so it's everything. And, oh, you know, that was probably not a classified pitch track. That's why it's not showing up. It shows up. Anyway, so when it has a classification, it will show you the call type.
They all have
Yeah, they all should be
classifications.
good.
It shouldn't.
No?
You quit out of your program strangely too. Use the quit button.
I did use the quit button.
No, you use the.
No, she used the
The
quit.
red
I think
button up
the
above.
first. Yeah.
Oh, she did.
I think she used the quit and then
I used
but
it
didn't
and
X
then
out of it.
terminal.
Don't criticize you. Sorry, I take it back.
Oh gosh.
Don't break my soft.
It's so fun to work while everyone's watching.
Is it?
I know, right?
Taking note of everything.
It's okay.
It's all recorded too.
Poor Mark. I'm like, I found an issue. So this is showing you a call type that's marked as a humpback call type. Mahalanobis is 8, so like if we were going through analysis, this wouldn't show up, right? But just to give you an idea, that's everything that it's currently pitch tracking.
It's a good example of like why we have the Mahalanobis distance, because this is
Yes.
what you would have to go through if
Right,
you didn't
yeah.
set your threshold at 3.
Yeah, and we could jump to where it's in the water, but still gonna give you 10 humpbacks. But yeah, again, some Mahalanobis. And you can see where it is, something short, but a Mahalo assistance of 7.2. So the maximum we've looked at for an analysis is 5, and that's again for a call type that has very little false detections. So yeah, that's why we do what we do. Okay. The next program.
No, you're good.
Okay. The next program, so we had the export summary auto detection, so that gives you how many detections in a certain time bin. But if you want to look at every detection and the information, you can export auto detections, and that will give you every pitch track with different information. And so for that one, that's export auto detections. You direct it to the LFDCS output folder. You specify the call types again in brackets of what you want to export. So if you don't want everything, you give it the call types. The output folder, and you can give it the location, but the output file name .csv. It's important to add the extension so it actually creates the correct file. And then you can add /manual, and that will give you the codes for whether you marked correct or incorrect. So if you went through and classified detections and you hit manual, it'll give you columns for that, the buttons that you pushed, basically. And so to look at what that looks like. That's here. And so again, you get your header metadata, so what you put in the parameter file, which writes it to your output. And then the call types that you ask, so this is telling you what's in each column. So the first column is the call type, so that should only have the call types you told it to output. It gives you the detection start and end time, and this comes in second since the start time you specified in your parameter file. And so this will tell you what you put in as your start date. So if it was 1970, it'll say 70 here. It'll give you the duration of that pitch track, the minimum frequency, the maximum frequency, the bandwidth, the amplitude relative to background, the Mahalo assistance. So you can filter, I only want you to export maximum Mahalo assistance of 3, so you'll only get those listed. Here it looks like it's showing you everything under 12.99, but it'll say if you specify Mahalo assistance, what you specified. And then the last columns are the species code. So if you went through and analyzed anything, these would change. So right now, there were detections marked as incorrect, so those are all negative 9999. If you went through and did anything else, it would show you here. So those would be in that file. Okay. Let's see. We have 10 minutes before lunch. I'm just thinking, so the next things are call library programs. Shall we just dive in? Anybody want to stop? Or your brain's like, oh my God.
Probably get through create call library or the.
Yeah.
And let's do manage call library. At least let them
Do manage now.
see what a call library looks like before we
that.
create.
Okay. So in your LFDCS folder, there's the call library folder, and that will have any call library that you created. And so we have like several. You might alter one and call it something else. They'll all live in your call library folder. To manage it, you just say manage call library and then direct it to the call library file. And we will. So the first thing that it puts in the terminal is it will list all of the call types in your call library. So here it gives you the call type number. It tells you how many exemplars you have in each call type. And then this is all information you give each exemplar when you create the call type. Or sorry, what information you give the call type when you create it. So you can say what species it is. You can give that call type a name and then the description of it. So if you have, for example, 5 call types like we do, we then give a little description of what the differences are so that you can at least understand when you're looking at it. Okay, so if we go into this and you then select which call type you want to look at, we'll say 5. You hit enter, and then it brings you all of these windows. And so one thing, you'll still want to navigate through things in your terminal, so that I usually make my fourth window here. Before we do that, I'm sorry, just holler if you can't see anything. I know it's small. So the first thing it does in the terminal for that call type is it lists all of the exemplars, and so it'll give you all of the information for those, including the date and time from the audio that it was taken from. So that's if you're ever wondering, like, oh, are these call types new, or are they examples from a long time ago? That can help give an idea of the distribution over time. But then the other information it gives you is start time, frequency, all of the
Attributes.
thank you, are listed along with the index of each exemplar and the date and time.
So those are the 7 attributes we talked about.
Are the exemplars pitch tracks or wave files?
Well, both. So an exemplar, Jen will walk us through how to find exemplars, but the exemplars are basically you're building a call type and you provide LFDCS with examples of that call type. Right? So you will have processed a data set with LFDCS, and the find exemplars looks a lot like browse auto detections. You'll just go through pitch track after pitch track after pitch track, and you'll say, okay, this is a great exemplar for this call type I want. So you select it, and then it goes in here. So its pitch track is recorded. The audio, like a snippet of the wave file is of the audio is saved, and then these attributes.
And so you were saying that, I think when you're saying one of the pros is that it's like not super sensitive to frequency bin changes. So, but ideally you'd, like if you have calls in the call library that were made with data that's sampled at 2 kilohertz and 1 kilohertz, as long as the call is in that range.
Yeah, as long as your attributes from both spectrograms are relatively similar for the same call, you should be fine.
Okay, or if the call library was made with 2 kilohertz, but you're working with 4 or 1, like does the call library need to be made with the same
Ideally,
settings? Ideally.
But if you used 4 kilohertz data and the pitch tracks will not have the same frequency resolution, but if the estimation of the attributes is relatively similar, then you should be fine. These are the numbers. The attributes is what it does the discriminant function analysis based on. And so if the pitch track looks essentially, that vector pitch track looks essentially the same, whether you did it with 2 kilohertz or 4 kilohertz sample data, then you should be fine.
Yeah, if your duration is in
the duration is the same, yeah. Right? Whether it's 2 or 4 kilohertz, and hopefully the other things are measurable, like the frequency span and the slope. If those are measurable and come out to have the same answer, you should be fine. Okay. But you should check.
Yeah,
you should definitely check.
So then you get these 3 different panels. This panel down here shows you what each pitch track looks like for all of the exemplars. So it's also a good way to quickly see and see if they all look similar enough. You'll also see it in all of these. So these give you the different attribute clouds to see how close they all fit. If you have an exemplar that's really out of bounds, it'll highlight in red. So as you're building, I would wait until you have a lot of exemplars in your call type before you start evaluating, because it'll change with everything you add. So until it's pretty robust, it's hard to really tell if it's going to be all type fitting or not. So like when you start adding things, you'll have a bunch of red outliers until you have a bunch of call types that really make a nice cloud. And then you'll be able to see, oh, okay, maybe there's a few I can delete. But if you start deleting, then it might give you a new outlier. So yeah, we typically suggest 50 to 200 exemplars per call type. That should give you a good spread. And then it shows you, in addition to the cloud clusters, it shows you the distribution for each attribute of the call types, of the pitch tracks. So that's another way to look to see if they're pretty normally distributed across all the different attributes.
And one of the things it's showing you also is the last histogram and the last jitter plot is the Mahalanobis distance. So for each of the exemplars, you can compute its Mahalanobis distance. How close is it to the centroid of this seven-dimensional cloud? And we just look at the histogram up here. You'll notice Mahalanobis distance 3. There's a bunch of exemplars to the right of that are between 3 and 5. So when you analyze your data and you use a Mahalanobis distance of 3, that means some genuine calls would be excluded and not class. You wouldn't consider them as that particular call type. That's why we say Mahalanobis distance is conservative, and you'll miss calls. You'll absolutely miss calls if you use Mahalanobis distance of 3. But that, again, depending on the purpose of your analysis, that might be totally okay. Just something to keep in mind.
It also depends on the scale you're looking at. So if you're looking at daily, you're likely going to capture true calls. Whereas if you're looking at hourly, you might miss more and you might not get hourly presence as exact as your targeting. But we've done a lot looking at hourly versus daily, and daily is really sufficient for overall occurrence understandings. Okay, so then there's a bunch of things within here that you can do. So at the moment, it's based on the letter that it specifies. There's the parentheses down here. So if you wanted to quit altogether, you would do a capital Q, enter. You can select an exemplar and a case. So if we go to select case, so that's capital C, it'll ask you for the index. And since I'll go to the last one on this list because it's listed, 3802. And so it'll highlight that exemplar and it'll show you where it fits on the histograms and then in the cluster. So from there, you can do a couple things. You can go back and forth in cases. So you can do N for next case, or you can do B for back case. If you want to switch to look at the spectrogram, you can do R. And so it'll show you the spectrogram of that exemplar, so you can kind of evaluate that way of what it looks like. You can play it, so then there's other commands that show up, so you can change the speed, the volume, play the case. You can loop through this exemplar to other calls to compare what it sounds like. And let's see, you can use the cursor to interrogate the spectrogram. So if you do C, lowercase c, we should be able to click on a point and then it'll give you information on the spectrogram there. So then within here, you can advance, actually.
Command click.
Oh no.
Oh no. Command click on the spectrogram.
Oh, perfect. Thank you. And you can, yes, so you can play with that from there. You can switch back and forth. You can also move between exemplars in the spectrogram view. You can also, as you're going, you can move a case to a different call type. So say one of them is highlighted and is really long. You can, when it's selected, do capital O, and we can do it as an example.
I mean, we can always move it back. Emergency alert.
Phones?
Yeah, the emergency.
So you can move a exemplar to a different call type. You can create a new call type within here. There's a lot of things you can do within the manage call library. So that's just as you're building. These are a lot of the different ways to look and evaluate and assess what you want to do from there.
That moving can be handy if you're building a call type and you see, like in these jitter plots in the upper left, you start to see that there's actually two groups, like each one of the attributes kind of separates into two groups. that's a really good indication. You probably have two call types that are really meaningfully different. And so you can start moving, offloading exemplars to a new call type.
Yeah, you can delete the exemplar, delete the entire call type, change the call type. So kind of basics of navigating within the managed call library.
Jen, can you also, with the IDL3 window, because all the numbers start to overlap if it's minimized enough, can you like expand the window and then click? Does that help the view, I think, a bit?
It does.
Just so that people can, like, so if you're trying to like pick a pitch track out of there and get the number below there, it helps a bit, spreads things out.
But it does list them all here, so that at least tells you a number you can start with and cycle through.
This program is a bit of a disaster, and my apologies for that. But working within the confines of IDL and doing all the things that you need to do to manage the call library, it's just, there's no way to make this easier unless you went to a full sort of windowed, a very different interface. So my apologies.
I think it looks pretty good.
Yeah, it doesn't
Yeah,
slide,
once you get the commands down, it doesn't take very
It's
long
not
to
hard,
create a
yeah.
call type, and especially if you have all your exemplars ready to select.
And,
Yeah, it
the
doesn't take much.
2.0 version, these are buttons in a GUI, so you won't have to remember which letter to press. You can press the button for the command you want to do, and it'll navigate through it that way. You'll still get the window, so it looks almost the same. It's just instead of in the terminal, you'll have a button guide to different options.
And do you recommend to have a different SNR sounds for in your library, or just good SNR sounds? Or
Great question.
Good, yeah. I would do a variety of all of the above.
Okay.
So you want faint calls, you want loud calls.
Yeah.
You do want good pitch tracks. So if it's a pitch track that's like, ooh, I went over here for a little bit, you wouldn't want to include that because it would get a lot more noise. So you do want pitch tracks that will be typical of what you're looking for, but you do want a variety. So loud calls, soft calls, loud environments, different other species around. You want to make sure you're getting different animals, right? So I want to go to one instance of calls and get all of my exemplars from that hour because you're likely getting one animal. So the variation will be captured from different individuals.
But so to build the library, you have to run the LFDCS and then say, okay, this one is the call I want in my library. I want to call it this way.
Yeah, so we can look at that after lunch. We'll go through that, how to do that.
Okay.
But the first step is always to process your data.
Yeah, okay.
Because then within that you can use all the different programs using,
I ask an annoying question.
Yeah.
Like, I have a computer science background, but like, what was the motivation to use IDEA in the first place?
Because I had used it,
Okay,
been using it for years.
because that looks really good what you did.
Wow, I've never heard that.
Better in Python, in my opinion.
Yeah.
But
Yeah, my choices were MATLAB and IDL, and I had been using IDL, so it was really easy for me to do.
take an intern and make him
It's
translate
more than a
a couple of interns.
Mark didn't know we would be like, everybody use it.
Yeah.
So great.
Yeah, so this program was mostly written for me, and that's why it's only till Jen came along that we started to make it a little more user-friendly, but it's still not great. I think, so it's like if you go back to your cheat sheet, like the cheat sheet is, I find that like sitting here listening to you guys, or like listening to the same thing that you guys, this looks like a nightmare, right? But that and the parameter file, but it's made so that the user can customize it in a bazillion different ways, and so you can kind of tailor this the way you want, and we're happy to help you. You know.
You could do a lot of cool things to like make that easier.
Yes, you could.
I will say the other thing that's really amazing is this processes data really fast. So we can go through 5 months of data in less than 24 hours. And that's including creating the spec audio and getting all of the pitch tracks. So it's just, yes, it might look cumbersome, but once you get a hang of it, it's okay. Welcome back, everybody. Okay, so we have a couple last programs to go through. So, and I think I said this, but in case I didn't, so each program that we're going through is basically like a code file that you call up, and then each one has different things you can do and different arguments you can tell it, depending on what you want to give it. So everything we went through so far, the processing,
No response.
and that one, and again, the reference guide has all the arguments for each program there, so if you're curious like how you can fix it or do different things, that's all listed there. For reformat, detect, classify, it's really one thing, you're processing the data, but you can add arguments like no convert, so if you already processed it with LFDCS and you don't need to convert it to the spec audio and you want to do a different call library or just do that portion again, something didn't work, you can do no convert and it'll just do the LFDCS tracking portion. We went through export summary auto detections, and again, there's a ton of different things you can give it or leave out. So like if you don't want to put a Mahalanobis distance in there, a maximum, you don't have to. There's also min Mahalanobis distance. I don't know if you'd want to do that, but that's something you can do, so you can give like a range of values for things. And again, all the different arguments listed in the reference guide. Okay, so we went through browsing, exporting, managing call library. So now we'll look at some of the other call library programs. So the first one is create a call library. So that's if you want to start from scratch. One option that I think a lot of us probably can do is you can build off of another call library. So you might take like call types from A species and add more of your own, or you might alter them or add exemplars from your region to ones that are already there. That's a good way to start as well. Or you can create a call library from scratch. And so that's what the create call library function is. And it's an easier one because that's all you type. And then it'll go through a couple questions. So in my handy code, directing us to where we need to be, opening up IDL, and then we create call library. Okay, so then it gives you some prompts. The first one is, what do you want to call it? And so this goes, I believe, automatically into your call library folder. So we can call it CLNB is for call library narrow band. And then call library is always the first thing you want to say. So that's like the file that directs everything to it. And then I like to do an underscore. What we've been doing amongst the group is then adding a name to your call library, whatever you're going to call it. So then when you look at that output and you look at the call library folder, it'll tell you immediately what call library you ran, rather than having to go in and look. So we're going to call this test. And then .nc, that's just because LFDCS writes net CDF files, so everything is .nc, just to make it happen. And so then it asks for a unique description of the call library. So we'll call it a test for the workshop. And then whether you want to make a narrowband or broadband, we're always using narrowband right now, but so I said N. Okay, that's good.
That's good.
I think we need to go into call library. The call library folder is my assumption. Anyway, we'll try this.
Is there not a
I remember
CLNB?
not
The
working
CLNB
Yeah.
directory,
Oh, do I have to call it?
does that not exist?
Yeah, you might be trying to get into something that isn't
Or
there.
that's already there?
Oh,
It's just call
it's
library.
Just an underscore. Okay, let's do that. Oops. Oh, also, if anyone's new in the terminal, if you do up arrow on your line, that'll bring you the last command. You keep going up until you go to repeat, so you don't have to type it all again. Okay, so we're gonna go. I assume this, right?
look at
call
that.
library.
This is very embarrassing.
CLFD test.
Is there,
No,
I
do
think
I
it's
have to
because
create
there's
this?
no, I think I don't think it'll create a CLNB test folder for you.
Let's just try that.
Yeah. Yeah, probably have to create, I think you have to
Okay.
create the,
You have to create the folder. So it doesn't create a folder for you. You have to create the folder you're going to put these into. New folder. So we'll call it CLFB test. Okay. All right, so that's all you do. That gives you all the files you need. And then from there, then we need to go into the build exemplars program. Sorry, find exemplars program. And that is what you do to build your call library. So once you create your call library, you can go into the data and find it. So again, to find exemplars, you have to process your raw audio with the reformat, detect, classify program, and that will give you pitch tracks, because we need pitch tracks down to the call library. So in manage call library, find exemplars. That's the program. You direct it to the LFDCS folder of where you want to get the data from to put pitch tracks in. And then the third argument is the call library file that you're building to. You can tell it what call type buttons you want. So if you already have call types here, it will list those, the ones that are those call type numbers. Otherwise, you don't have to put anything here, it'll list everything. But if you have like 26 call types, it only shows about 8 buttons. So you want to specify if you want some of the lower numbers in there, which ones you want. And we can look at, show what that means. You can go through and specify things for the pitch tracks you're looking at. So if you know you're looking for calls that are within 50 and 400 hertz, you can specify that in the min and max frequency range, and that way your pitch tracks will only show in the range that you specify. So if you're looking for a specific call type and you want to scroll through stuff more easily, you can give that range in that way. So we can look at this to start with as an example. So this is going to look at if you want to do, is this a test in here?
Yeah, I think I created that actually in the last training, so I could just mess with it and not.
Oh, it is test.
Change
Okay, you're
anything.
already in there.
Yeah.
Okay, so we'll just do that. Okay, so this is building on a call library we already have. So we have a call library, Gulf of Maine 9. That's what we're currently using for all of our Western North Atlantic baleen whale species. And it looks very similar to the Browse auto detection program, you'll notice. Here on the right are those call type buttons that I just cut off. But so 1 through 9 is listed. So if we could look at like 25 through 30, if you had those lower numbers, we would specify that to bring them up. It's the same exact way you navigate as the other one. You can click on either side of the spectrogram. You can use your scroll on top of the spectrogram. Look at all these beautiful upcalls. You can also page forward. So if you have a ton of pitch tracks and you want to go to the next full page, page forward, page backward, same thing. You can zoom in and out by frequency, time, using zoom in and out. Jump, so you know you want to go to a different date. We can go to jump, which then brings you to the terminal where you jump to. In here, let's say, so we're at 03, 30, 09. Let's say we want to go a few hours or 1 hour ahead. So it'll jump you there. Nice call, don't know what it is. And then volume, speed, same thing. So if you're playing, you want to listen, you know your speed and volume you want, you can do that here as well. Audio filter, I usually ignore that.
Oh, what does that do?
What does that do?
So we don't worry about this button.
It's in the reference guide.
Yes, it's in the reference guide. When you play it again, same like the other program, it'll play the pitch track that's selected with a second buffer on either side. Play range, again, you click it, and then you click where you want to start and end, and you'll notice it doesn't show you anything, it'll just start playing. So just keep that in mind. Turn up the volume if you don't hear it, or then I usually, if you can't tell if you click, so sometimes I'm saying this as a warning because if you click play range and you click on that button again without realizing it, and then click over here, it'll start playback somewhere in the past of your spectrogram window, and then it'll play until it gets here. So just wait until that plays out. Frequency range, again, you can change the frequency scale you're looking at, so I just changed it to 800 hertz. You can hide your pitch tracks again. I find that this is a really handy thing when you're doing analysis to look back and forth at the actual calls underneath the pitch tracks.
Oh, click.
Compare audio, if you click on that in the terminal, it gives you a prompt and you're able to compare the audio to a certain call type, so it will cycle through that pitch track and then the exemplars in your call type. So it'll go back and forth so you can listen to the differences and see if it sounds close enough, and we'll hit one.
Do you guys ever use it?
You hit Q to
You can
stop.
use the where it'll play player exemplar.
Okay, so let's say you're going
I did at
through
the
and you
time,
find this
yeah.
really
It's been a
cool new
while since
call
I
and you
used
want to
it.
add a call type to your call library, you can do that within this program. So you just say add a call type. You say, are you sure you want to add a new one? We'll say yes.
Doing this over the on the
It's thinking about it.
Oh,
We may
yeah.
not
Is it
get to
thinking?
start.
I don't know. No.
Well, we'll restart.
While we're waiting, the audio filter button will, if you press that, it'll only play the frequency band that the pitch track is in. So it'll filter out all of the background noise that's above and below that frequency band.
So smart.
Yeah, well, that was the reference guide. Thank you. That's why we have it. So we don't use this very often.
Oops, I just clicked on a bunch of calls.
I might have missed this, but where is it within the call library, or like what each of the numbered call types are? So like,
This is from our already built call library. Yeah, so if we,
so if you were adding a new one, where would you name that?
here, okay, so we'll do it two ways. So this is,
Start fresh.
so this is on a, I apparently added these into the call library.
That's why I made a text
We can show
button.
how to delete it. Right, so, so when you do click on a button, it will box it in that color to show you added this exemplar to that call type.
Uh-huh.
We will go into the manage call library to delete that if you need to.
Okay.
But if you're adding a new call type here, you would say add call type, say are you sure? Yes. And then you add a number. So theoretically you know how many call types you have. But you cannot, I think actually if you give it a number that's already there, it yells at you. Yeah, it tells you it already exists. So that's good. If you wanna, so I would go, let's say we wanna add call type 50. Okay, so that's a new call type. It doesn't already exist. It didn't give you a warning. So what species? So test, name of the call, test. Testing. Right? Yes. Contributor, tester. So then after you enter all that and say, well, I really messed up. If I don't actually want to add that, you could say no, and it won't add it. But if you say yes, it'll add it. And theoretically, if we didn't have all of these buttons here, it would show up on the bottom. So if you only had 3 or 4 call type buttons here, that new call type button would add here. So I think it's probably down here.
Yeah.
And if you knew you were gonna wanna add anyone, then you could just not put 8.
Exactly.
What you're
So we
saying,
could,
okay.
so like, so that'll show you, so you put 1, 2, 4, and then 50. And we could just, okay, 1. And then up comes 51. So you can play,
I didn't know
you can add it that way. You can also
I
then,
didn't know it added it.
and so this is as you scroll through, again, you can click on, I think that looks like 51, highlights it, keep going, and we'll say, that also looks like 51. So this is good. So
So 51.
51 sucks. Okay, so then we'll quit. So that's how you add exemplars. And again, you can filter based on frequency bands. So you'll only see pitch tracks that are more likely in your call type, that kind of thing. I should say, so the other thing it does, so as you're going through, especially when you already have a rather robust call library, is that when you're on a pitch track, it will show you information of what call type it most likely currently fits under. So this is helpful when you already have a lot of exemplars. When you're starting to build it, I wouldn't pay as much attention to that because you don't have enough exemplars to really help inform yet. But this can be good to help guide a little bit. So just keeping in mind, depending on where you're at, what you look at. But it gives you the call, the top 3 call types it would fit near. The probability is no hollow Novus distances. These are, of course, really high distances, though, so probably is not one to follow. Okay, so let's say, all right, so you build a bunch of calls. Let's go back in now, and we'll go to the manage call library that we just added a bunch of horrible exemplars to. So now when I manage that call library, we see those 2 call types that I added, 50 and 51, and no exemplars for 50 and 2 for 51. So if we look into the old one, I believe it tells you there's not enough to compute. Yeah, there's not enough data to make the plots yet. So that's good. But what we can do just to show you is that you can delete an entire exemplar or call type. So if we go, if I go to maybe.
Are you using D or E?
Ooh, something, I don't know what I did. But index of case, if we go to 5, I wonder if it's just there's not enough.
Maybe you need just more than 7 for anything.
Not sure I tested this.
Usually you wouldn't even go into it this early. Like even if you added calls, exemplars by accident as you were creating a call type, I wouldn't even bother going into manage call library yet. Because you're either going to run into this issue or you're going to be flip-flopping back and forth. So if you added something on accident, once you're all done adding your other exemplars that you want in, then you could go to here to the manage call library program, and it'll be really obvious, or it should be probably, which one you added by accident, because it'll be an outlier that's very.
Yeah, you can also, so it didn't select it, but it's on the case. So I said I wanted to delete that exemplar, so capital D, and it says, are you sure? And I'll say yes. So it deletes that, and then to show how to delete an entire call type, you do capital E, and it says, are you sure? And I say yes. Are you really sure? Thank you, Mark. So you can do that way too. So let's say you totally added something and didn't mean to. So that's kind of how you can go back and forth with that from there. And that's my hardcore quitting.
Violent.
I just testing it out. Okay, find manage. So let's say you built your new call library, and now you want to reclassify what you've currently done with it. There's 2 ways to do it. You can use reclassify auto detections, and that you direct it to your current LFDCS output folder. And then the second part is the new call library file that you have, and so it'll reclassify everything with that new call library. The one thing with this to keep in mind, so if you've already gone through and analyzed pitch tracks using a call library, and you've marked correct, incorrect, unknown, it will keep those classifications with that pitch track, even if it changes to a new call type moving forward. So you don't lose your analysis on that pitch track, but it might not be correct anymore. So that's something just to keep in mind if and when you're doing this, how you would then look at classifications and just check. Another way that you can reclassify is that you would do reformat, detect, classify, which is what I just talked about right before of the different arguments you could put in. So this is the processing program command where you have a parameter file and you would make sure your new parameter file has the new call library file in it. So you just direct it to the new call library, and then you can say no convert because you already have the spec audio produced, and then it'll do the LFDCS pitch tracking classification based on that call library file and that parameter that you now directed to.
That should take a lot longer because it's generating the pitch tracks again.
Yeah, it would take a lot longer. Yeah, true. So not recommended. However, if you wanted to keep that, so actually in all of these, I would recommend copying your LFDCS folder and making a backup folder no matter what, so that you would have the original output with whatever classifications you have, and then if you reclassify, it'll have a new folder, but just something to think about. Backups are always good, just in case.
2.0.
Okay, yep, those are all the main programs that we're gonna go through here. Does anyone have any questions on call library stuff first? We flash.
Do you share your call libraries with everyone?
Absolutely.
Oh,
Yeah, you can have any of the call libraries. Yeah, we have. So we have the main one we use for 2 kilohertz sample rate, and then the low frequency one for FIN and Bluetooth. But yes, absolutely.
And if you want to build a call library, we're happy to kind of consult with you on how to do that. I guess there are a few things to keep in mind and a few pitfalls that you might not realize that we might be able to catch. So we've done that with other folks before, so happy to do that.
Absolutely. Okay.
Yep.
So. Coming to you soon. We've been working on the next version, we've been working on an LFDCS that will be able to operate on any computer, so it's not Mac limited. So we can use it on Mac, Windows, and Linux. It will only require an ideal runtime license, like we talked about earlier. It's a lot cheaper. I don't know yet, but I'm assuming it's going to be easier to install and get everything going. We'll try to make it that way at least. And then what's cool is that there's a GUI for each program. So instead of going into the terminal and typing all the commands out like I showed you, you'll click on the program you want, and it pops up a GUI window that has all of the different arguments you can enter. So you just put your values in that you want. So this is the browse auto detections. And so what you would do, and we'll have it, again, this is in progress, so we're not finalized yet. We'll have it very clear which ones are required and which ones you can ignore. But this is where you can, this is the Windows example from the Windows computer. So you can hit browse and you can actually navigate to the index file to point it to. You would enter, if you wanted to start somewhere, you would enter it here. You can specify if you want to do broadband. We'll have it defaulted to narrowband because that's what we're really using. You can enter call types in here. And then these are all the arguments that I may not have gone over, but that we have in the reference guide of what you can enter to look at. So if you're interested in that, you put in a number, it automatically changes to enabled so that that argument is added into the calling of the program and will be incorporated. So again, all of the things that we typically just type into the terminal will be translated into here. You can fill in your values as you want. And then the other thing that happens, so things like when we're in the program and it brings you to the terminal to jump to a place or the volume and speed commands, a little window will pop up instead, so that'll guide you into filling out what you want as well. And just one more example. So they all look like this, just depending on the program, the different arguments that can go in will be listed. And so this is export summary auto detection. So that's where we get a summary sheet of the detections based on the bin you want. Again, you would direct it to the file, the LFDCS output file. put in what call types you want, give the name and location of the file you want it to write to, and then the bin size and the bin time unit, so hours, days is a drop-down menu, start and end dates of the sheets, and then some of these things will be default, like narrowband only, because theoretically that's all we're going to want, and then Mahomet distance filter, and then some of these things are still in the test version, so probably won't be there. What you'll be able to do with this as well is after you fill out your settings, you can save them or save them as. So if you have different settings for different species or different programs, you could save that settings and then always restore it. Either restore the last one or restore from for a different file. So that way you could have kind of your set ways that you look at things and run things. So we will let you know when that's ready.